Hey students, so we are going to do the overall view and logic of a hypothesis test. Okay, so all hypotheses have two parts: a null hypothesis, which is written as HO, and an alternative hypothesis, which is the opposite of the null, and it's written as HA. Now, HO is what we assume to be true. That's our default conclusion. That's what we'll assume to be true. And thus, the opposite of that HA is what we could possibly infer. We could possibly reject HO and infer HA, and we'll see that in action. Now, a little bit of terminology. We need to know what alpha is the probability that we are wrong. Anytime we make a conclusion based on a sample, we might be wrong. And so statistics is making inferences about a population from sampling. The whole field of statistics is because we sample. So we're going to be taking a sample and doing a hypothesis test. And we're going to draw a conclusion. So we could be wrong. So alpha is the probability that we are wrong in this case, which is alpha is the probability of making a type 1 error. Now, a type 1 error is wrongly rejecting a true null hypothesis. So we may set our null hypothesis to be something, and if we reject that, we might be wrong, and that would be a type 1 error. Okay. Now, the industry standard is to use alpha of 5%. So alpha is 0.05. And that way, we are 95% confident we are correct, like 95% confidence intervals. One other terminology is a p-value, and that is the probability of obtaining a sample result or more extreme, assuming HO is true. Okay? And we'll understand this logic of a hypothesis test, but here it is. We assume HO, and if our sample results are very unlikely under the assumption of HO, then HO is probably false. Simple as that. So we'll reject HO. How unlikely do the sample results need to be to reject HO? Well, basically less than our willingness to be wrong. Less than making a type 1 error, less than alpha. So here's the rules right here. We reject HO if the p-value is less than alpha, and we do not reject HO if the p-value is greater than alpha. Okay, so let's do a couple of examples. All right. First example. I'm going to flip a coin. Now, you're not going to be able to see me flip the coin, but you'll assume that I do it fairly. Thus, HO is HO is that I flip the coin fairly and then I don't lie. Okay. So the alternative to that is either that I'm lying, or that the coin is not fair, or that I'm not flipping it fair. Okay. So I'm going to flip the coin, and here's the sample results. All right. And the sample results, I got a head on the first one. Flip it again. I get a head on the second. Flip it again, then I get a head on the third. Flip it again, I get a head on the fourth. Flip it one more time, I get a head on the fifth. Let me spread this out so you can see it. Then we flip it again, no way, I got a head on the sixth. Flip it again, no way, head on the seventh. Flip it again, head on the eighth. Flip it again, head on the ninth. Flip it again, head on the 10th. Okay. So 10 flips, and I have 10 heads. Now that's probably pretty unlikely, right? So let's actually calculate the p-value, the probability of obtaining a sample result or more extreme. So our p-value, what's the probability of getting 10 heads in a row? Yeah, that would be, the flip of a coin is 0.5 to get a heads and 10 in a row. The multiplication rule, we raise it to the 10th, then that's equal to 0.001. Basically. Okay? Pretty darn low. Now, alpha is 0.05, our willingness to be wrong, and that is less than alpha, right? So, this sample result is really unlikely under this assumption. Okay, so that assumption is probably false. And actually, our p-value, of 0.001, and that's pretty unlikely to get that sample result if HO is true. It's less than alpha of 0.05. So I'll reject HO, and I'll reject HO and go with that it was either lying or that the coin was not fair. Maybe it was a trick coin. Reject HO and conclude that either it was lying or that the coin was not fair. Okay? That is the basic idea of hypothesis tests. Alright? You set the null hypothesis, and then you get your sample results. And if the sample results are really unlikely under this null hypothesis that you're assuming, then that is probably false. And then you reject HO and infer HA. And in fact, that's the only thing that you can possibly do is infer HA. So there we go. Alright, so in the hypothesis testing, if you think about it, always look at this example. Really unlikely that I got in the head plus and one. Alright, let me tell you the reality of it. No, I won't tell you the reality. I flipped the coin, and in the hypothesis testing, you get sample results. Now you're going to draw a conclusion. It is possible that I got 10 heads in a row. It's just unlikely. You won't know for sure. You have to go with the probabilities. And the probability, it's really unlikely. It was 1 in 1,000, basically 1 over 1024, 1 in 1,000 chance that I would get 10 head flips in a row. Alright, so pretty darn unlikely. So you're probably pretty safe in assuming that I was either lying or that the coin was false. Alright, so that's our main example. Let's do a second example. Okay. I flip a coin, same thing. I flip a coin, I'm going to do it 10 times. Alright? And I did this before. And say I got 6 heads and 4 tails. Now would you conclude that I'm lying? Well, we have to calculate the probability, the p-value, right? The p-value then would be equal to obtaining the sample results or more extreme. So that would be the sample results would be the probability of 6 heads, or more extreme would be the probability of 7 heads, plus the probability of 8 heads, plus the probability of 9 heads, plus the probability of 10 heads. More extreme than 6. 6 would be, what would be more extreme? Not lower, but higher this time. So, flipping a coin is really binomial, right? Either you get heads or you don't. So then what's the probability of getting 6 or more, right? Well, that's what we would just add these up. We could calculate the individual probabilities, or we could use our calculator. 1 minus the binom CDF in our calculators. CDF of NPR. N is we did 10 head flips and 0.5, and we want to count up to 5, so 0 to 5. So we put a 5 here, right? And that probability is 0.377. Okay. So that is not very unlikely under the assumption of the null hypothesis that it was a fair coin. In fact, if I flipped it 10 coins, 10 times, the expected value would be, 5 heads, but I get 6 heads and 4 tails. That's a pretty likely result. So you would not assume that I was lying. You would say, yeah, it was probably a fair coin, or you wouldn't have evidence to infer that I was lying. It's fairly likely. So here we have, since the p-value is greater than alpha, I do not, and I capitalize not reject HO. Okay. So I cannot infer that I was lying or that the coin was unfair. Okay, so that's basically 2 examples and the 2 ways that the hypothesis test could go. Either you reject HO or you don't reject HO. And I hope you find that helpful.